Today's date is the 25th. So if you guys have been paying attention, what unit were we working on in the last couple of sections in terms of AP? What sections were the previous 5? So our book does it in a little bit different order. I'm just following our textbook. So this actually is the CED section 4.7. Okay. So you guys will learn when it's appropriate to use L'Hopital's rule to evaluate a limit. So we're actually going to be doing limits again. And then you guys will use it to calculate limits. Understand the different types of indeterminate forms. So you guys will learn what that means. And then lastly, just like we do all the time, we have to justify. When are we allowed to use it? And what must we say before we use it? Okay? This is very important you guys pay attention, because if you guys don't show your work correctly for this, the AP graders will mark it wrong. Okay? Even if your math is correct. Bless you. All right. So we're going to start off this lesson with a couple of practice problems. So go ahead and write this down. This is going to go in your notes. Okay, so do you guys remember what to do first for something like this, if you can? Factor, okay? Because if you plugged in 4, what's 4 squared? 16. Are we allowed to have 16 minus 16 on the bottom? So what we're going to do is we're going to factor this first. So remember, carry your limit through all the steps. You guys remember that? So at the right, this equals the limit as x approaches 4. What is the top factor to? I heard... what? X plus 6, what? X minus 4. What is the bottom factor to? Good. Do I have a common factor? What? X minus 4. So what happens to those? Cancel. All right. Am I allowed to plug in 4 now? Yes. If I plug in 4 into the top, guys, what's 4 plus 6? So this becomes 10 over 8, which reduces to 5 over 4. Cool. That's going to be on your final. All right. Same idea. Am I allowed to directly plug in infinity? Because is infinity a number? No. Do you guys remember what we're going to do here if it's infinity? It's okay if you guys don't remember. I'm picking your brains. What'd you say? You're on the right track. Highest power where? On the bottom. Good. What's the highest exponent you guys see on the bottom? X squared. So I'm going to divide everything by x squared. So I'm going to highlight that so you guys remember. Okay, so this equals the limit as x approaches infinity. If I divide this by x squared divided by x squared, you guys agree is just 1. Minus 1 over x squared divided by 2 plus 1 over x squared. Okay, so did I mess up? I'm good? Okay. If I plug in infinity now, 1 divided by a gigantic number, what's that number basically going to be? 0. So this is 1 minus 0, which is just 1, divided by, what does this become? 0. So 2 plus 0, which is just 2. Okay. All right, now I feel better that we went over that stuff. Okay, so now we're going to be dealing with some funky situations. Is everybody good here? So write this down. what if we were asked to find the limit as x approaches 0 of e to the 2x plus x minus 1 divided by x squared plus 4x. So in the last couple problems, we had some tricks, right? If it was infinity, we had a trick for that. If it's just a number, we could try to factor this. I agree the bottom factors, right? What could I take out of the bottom? An x. The top, however, does not factor. Okay? So remember, the first thing that you would try to do first is just directly substitute in the number and see what happens. Because sometimes bad stuff doesn't happen. So if I plug in 0, do you guys agree that's going to be e to the 2 times 0 plus 0 minus 1 over 0 squared plus 4 times 0. What's 2 times 0? 0. Anything to the 0 power is 1. 1. So 1 plus 0 minus 1 all over 0. What does the top become? Over. So what do we do now? Yes, I know you know. Hold on. So here, this right here is what we call an indeterminate form. So we need another strategy, which our homeboy L'Hopital discovered. Because you guys didn't know about derivatives yet, you guys couldn't learn about this yet. Now that you guys know derivatives, we can do a new trick, okay? And my notes disappeared. There we go. So indeterminate forms and L'Hopital's rule. So this is an AP course, right? Is this necessarily the exact same thing as what you guys will see in college, though? No. Indeterminate forms, if you guys take calculus again in college, calculus 1, you guys will learn that there's more indeterminate forms that we're not going to cover in this class. The only ones that we're going to cover in this class are 2 special cases, because that's what you guys get tested on the AP test, okay? But there's other ones, but just because of time, we're not going to cover all of them, okay? Only the ones you guys need. So if the limit as x approaches a of f of x divided by g of x is equal to either 0 over 0 or the other one you guys may get tested on is infinity divided by infinity, then the limit is of indeterminate form (0 over 0 or infinity over infinity. And so that means the limit may or may not exist. So one thing I want to ask you guys is, do you guys remember that if we did a limit and we got infinity or negative infinity, remember I told you guys on the AP test that one of the answer choices could be does not exist? So remember, if it is infinity or negative infinity, you could also say it just doesn't exist, okay? So 0 over 0, that's bad, right? Infinity divided by infinity, you guys might think, isn't that the same number? Is infinity a number? So you can't say that it's 1. No, don't do that, okay? So indeterminate form. So this is what L'Hopital's rule says, and Yev is already on top of it, okay? If f and g are both differentiable functions at x equals a, and g prime of x is not equal to 0, then the limit as x approaches a of f of x divided by g of x is equal to the limit as x approaches a of f prime of x divided by g prime of x, provided that the limit exists or is equal to infinity or negative infinity. So this is L'Hopital's rule. What do you do to the top? What do you do to the bottom? Take the derivative. That's what that says. Okay, so this is very important that you guys understand this. This is division, correct? And we're doing derivatives. This is no. This is not the same as the quotient rule. You're not doing low D high minus high D low here. You're doing the top, do the bottom, and see what happens, okay? They're separate. You treat them separately. Okay, so if you're doing a limit, that's different than the quotient rule. Does that make sense? Okay. You guys will know when to use this. Trust me, we like this one. This one's fun. Okay? Okay. Everyone good here? Okay. To save us time, I just gave you guys this next box, and I want you guys to highlight a couple things. So this is an awesome rule, but like I said, I don't want you guys to lose points on the AP test. So there's certain criteria you have to write down before you guys just apply it. So understand that this is a theorem. Theorems require that we always check the conditions before applying the conclusion. So kind of like the MVT, we had to say that F was what? Continuous and also differentiable, okay? For the IVT, you guys learned that you just have to say it's continuous, and then you have to do the other initial conditions, okay? So, in order to use L'Hopital's rule, we have to get 0 over 0 or infinity, okay? Understand that this is of indeterminate form. So in other words, I'm going to scroll back. Don't write this down. Just watch what I do. If you're showing your work, do you guys see how I wrote equals 0 over 0? You cannot write that on a test, homework, nothing. Because is this a number? So you can't write equals. So I'm going to show you guys how to show your work for that, so that way you guys don't get in trouble on the AP test. Okay? So do not write, highlight this, do not write equals 0 over 0 or infinity over infinity. So, this is what you're going to do. Write the limit of the numerator and the limit of the denominator separately. If both limits approach 0 or infinity, apply L'Hopital's rule. And I'll show you guys what I did in college as like little shorthand when doing this. After applying the rule, find the limit of the numerator and denominator separately again. Once the limit of the numerator and denominator do not create an indeterminate form, the ratio of these limits is the answer. Sometimes you'll have to do this twice. When I was in college, I think there was problems where you had to do it 3 times in the same problem. You had to do the derivative, and then it didn't work. So do it again, and it didn't work. So you had to do it again, okay? In this class, you guys may have to do it twice, okay? So, now that you guys know that, we're going to start the notes with the same 2 problems that we just did together. Hold on. There we go. I want this to go away. Sorry guys, I got water for my coffee on my iPad screen, so it's like tweaking out. Okay. So, This is the first problem we did, right? So if you guys wanted to use L'Hopital's rule here, you could. So let's say you guys just didn't want to factor. If this is an AP test, you're stressed out, you're like, oh, I remember going over L'Hopital's rule. You can use L'Hopital's rule here. So this is how you do this. Remember, if we plugged in 4, you're going to get 0. If you plug in 4 here, you're going to get 0. You cannot write this. Don't do that. Okay, so this is how you're going to do this. To show your work, you're going to say the limit as x approaches 4 of the numerator, so x squared plus 2x minus 24 is equal to, if I plug in 4, guys, what's 4 squared? 16 plus 2 times 4 minus 16 plus 8 is 24. 24 minus 24 is 0. Okay? Do the same thing for the bottom. The limit as x approaches 4 of x squared minus 16 is equal to, 4 squared is 16 minus, which equals 0. Okay? The AP readers will understand what you're doing. So isn't this the top? Isn't this the bottom? So they'll understand that this creates 0 divided by 0. You don't have to write that. Instead, what you're going to say is, this is an indeterminate form Which indeterminate form did this create? 0 over 0. So, L'Hopital's rule, LH rule, applies. This is what I'm looking for in your homework. This phrase, okay? So this is what you're going to do. Rewrite the original problem. So the limit as x approaches 4 of x squared plus 2x minus 24 over x squared minus 16 is equal to, I'm going to do this above the equal sign. Thank you. This tells the reader that you're applying L'Hopital's rule. So what did L'Hopital's rule say to do to the top and do to the bottom? Take the derivative. So this is equal to the limit as x approaches 4. What's the derivative of the top? 2x plus 2. What's the derivative of the bottom? 2x. Don't do this. Don't do that. Plug in 4. What's 2 times 4? Plus 2. What's 2 times 4? Reduce. We get 5 over 4. Hey guys, guess what?
That's the same answer we got in that factory.
So you might think about it like, oh man, that's a lot of writing. Do I want to do that? If this is a multiple choice part of the AP test though, do you have to show all that? All you have to do is do the derivative, do the derivative. They don't care what your work is for the multiple choice. They just look at what you rolled in, right? But if it's a FRQ, you have to show your work here, okay? Questions? All right, so do you guys remember that problem we did? That was the E. Let's do that using L'Hopital's rule. So B. The limit as x approaches 0 of e to the 2x plus x minus 1 over x squared plus 4x. Okay. So do the limit of the top, limit of the bottom. The limit of the numerator. On your homework, you would show all the math, right? But what do we know about the top from earlier? Wasn't it equal to 0? Okay? So I'm just going to save that step because you guys already showed me that earlier. Same thing on the bottom. The limit as x goes to 0 of the denominator was equal to 0. Okay? So what do we have to say? This is the indeterminate form. Which one? 0 over 0. So the L'Hopital's rule applies. Okay? So that means the original problem, the limit as x goes to 0 of e to the 2x plus x minus 1 over x squared plus 4x is equal to, if I apply L'Hopital's rule, this is how my professor did it. He wrote that when he was taking the derivative. Okay? Is equal to the limit, what you're approaching doesn't change, so it's still 0. The limit as x goes to 0. Now, I know some of you guys are still struggling with the chain rule. This is a chain rule. Remember, outside, inside. What's the derivative of e to the x? E to the x. So the derivative of the outside at the inside is going to be e to the 2x times the derivative of the inside. What's the derivative of this? 2. Okay. Plus, what's the derivative of x? 1. Over, what's the derivative of the bottom? No. 2 what? Plus 4. Okay, try substituting again. E to the 2 times 0. What's anything to the 0 power? 1. What's 1 times 2? So this is equal to 2 plus 1 divided by 2 times 0 is 0. 0 plus 4 is 4. So this simplifies to 3/4. Cool. How are we feeling? Is there anything new here? Haven't we done a chain rule? Haven't we plugged in limits? There's nothing new here except just understanding, hey, that's a new little trick I have up my sleeve. Okay? All right. So, question for you guys. Which one of these can I use L'Hopital's rule for? So this is a trick question because just because we see limits now does not automatically mean you do L'Hopital's rule every time. You only do it if it becomes an indeterminate form. Okay, so watch. If I plug in 0, what's the sign of 0? That's 0. If I plug in 0, what's 0 squared? What's 0 times 2? What's 0 minus 1? Did I get an indeterminate form? So do not do the derivative of the top and bottom because it will not be the same answer, okay? What's 0 divided by negative 1? 0. So did I have to use it here? No. Okay. The next one. If I plug in 2, you would get the sine of 2. On the bottom, do you guys agree that if I plug in 2, it's going to be 4 minus 4? Okay. Which is 0. Okay. But is the sine of 2, is that 0? So this is not indeterminate form. For these limits, guys, remember, these create asymptotes. So this limit is either going to be infinity or negative infinity because this is going to approach something. Is the sine of 2, is that going to be positive or negative? Positive. So I have a positive number divided by another positive number but really small. So is that going to be infinity or negative infinity? This is going to be a positive number divided by a really small positive number. So it's going to equal positive infinity, okay? So did I have to use L'Hopital's rule? No. Okay. Here though, if I plug in 2. So another way you can show it is you can draw a little arrow. This implies, doesn't equal, it implies, if I plug in 2, guys, what's 2 minus 2? What's the sign of 0? So this means the top goes to 0. If I plug in 2 here, what's 2 squared? Minus 4 is? The bottom goes to 0. Do you guys see how I'm not writing equals 0 over 0? Does that make sense? You good? Congrats on the butt kicking over the weekend. So do I have to use L'Hopital's rule here? Yes. Okay. All right, let's do some harder ones. And then you guys will do whiteboard problems. Okay, these will be quick. Most of these are going to be no calculator. So what's the first thing you should try to see if you have to use L'Hopital's rule? Plug it in. Okay, so if I plug it into the top, the limit as x goes to 1 of the natural log of x. If I plug in 1, guys, what's the natural log of 1? It's 0. Okay. The denominator, the limit as x goes to 1 of x minus 1 is also 0. Okay. So this is the indeterminate form. Zero over 0. So L'Hopital's rule applies. So the original problem, so rewrite the original problem. The limit as x goes to 1 of the ln of x divided by x minus 1 is equal to, by L'Hopital's rule, the limit as x goes to 1. What's the derivative of ln of x? 1 over x divided by, what's the limit, or what's the derivative of the bottom? 1. So if I plug in 1, what's 1 divided by 1? 1. What's 1 divided by 1? 1. This is 1. Yay. Here's a weird one. B. Uh-oh. Okay, we have to kind of have an idea of how graphs work for this problem. E to the x, this is an exponential graph, right? So do you guys understand that exponential graphs look something like this, right? So as x goes to infinity, where is this arrow going to be pointing towards? Infinity. So the limit of the top, the limit as x goes to infinity of e to the x is going to be infinity. Okay? The denominator, the limit as x goes to infinity of x squared, is that going to be a small number? What's that going to be? It's also going to be infinity. Okay? So this is the indeterminate form what? Infinity over infinity. Okay? But same thing. So, L'Hopital's rule applies. So understand this, we don't know what this is. So pay attention to what's going to happen right now. Take the original problem, the limit as x goes to infinity of e to the x over x squared is equal to, by L'Hopital's rule, the limit as x goes to infinity. What's the derivative of the top? E to the x over 2x. Then what do I try to do again? Plug it in. So watch, guys. If I plug in infinity here, what do we know about this? It's going to go towards infinity. If I plug in infinity here, 2 times infinity, isn't that just going to be infinity again? So do you guys see how I have infinity over infinity again? So that means that you have to do it again, okay? I'm not going to make you rewrite this again. All you have to say is equals L'Hopital's rule again. Take the derivative again. So what's the derivative of the top? E to the x. What's the derivative of the bottom? 2. Okay, now watch. If I plug in infinity again, e to the infinity is going to be infinity. Infinity divided by 2, that's still infinity. Okay? This is okay. Infinity divided by infinity, we don't know what that is. Does that make sense? This is okay. All right. There's a part C to this, but I want you guys to do some practice before you guys go. Okay? So, when I call your name, can you guys come to a board, please? Just ask her for another. Sorry. All right, Carlos, Rebecca, Ivan, Christian, Alina, Della, Alexis, Leticia, Jaime. Grace, Anahi, Sean, Nava, Betsy, Miguel, Bowie, Maria's out, Emily, Rodrigo, Jomana, Kendall, Rocio, Anthony, are you the one I didn't pick? So awkward. Okay, just pick an either. Pick an either.
Mr. Vigil, I need to pick up my grandma from the doctor's real quick, but I'll come right back. So I'll be here like 15 minutes. Okay, I'll be back.
I don't care. Okay, try these two, please.
No, wait, you didn't go. I didn't go. Yeah, you thrifted it? Yeah. I heard you didn't go.
I'll do it.
The limit as x plus x minus 2 over 3x minus 6x squared plus x. Oh, yeah. Yeah, plus x. Oh my. I keep forgetting. This is determined. Oh, I forgot. I have. Yeah, I'm taking it.
Someone else want to write? Different color?
Minus 48
Minus 24. Yeah. So I think it's 13.
Wait, minus 24. 12. 13.
12. Yeah, 13.
Everyone, I think it's the same.
Wait, no, wait.